All right, so part 3 of I'm not sure how many parts. I'm keeping the parts a little bit short, I hope, just so you can take these in just small bites. So part A of 14 wants me to graph the function absolute value of x plus 3. Call that f of x. And to figure out how to get this graphed, I'm going to take the x plus 3 that's inside the absolute value, set it equal to 0. And that's going to be the number not at the beginning of my x column, but the number in the middle of my x column. So when I go to graph this function, I don't know why my graph is so small for this one, but it is. I'm going to graph x and f of x. And in the middle of my x column, I'm going to put the number -3. And then I'm going to get smaller and go -4 and -5. And bigger and do -2 and -1. It's an absolute value, so it's going to form out to be a v. Let me get my table. So now I'm going to go y equals clear math number absolute value x plus 3, second table. Next to -5, I see +2. Next to -4, I see +1. Next to -3, I see 0. Next to -2, I see 1. And next to -1, I see 2. It should form out a v, and the point of the v should be at the point -3, 0. So first point, -5, +2. Oh gosh, I don't like this window already. I wonder if I've got some graph paper floating around here that I could pull out. I don't know that I do. Yes, I do. Lovely. I'm going to graph these points on, I don't like this graph, so I'm going to graph the points x and f of x. And I'm going to graph the points -5, +2. -4, +1, -3, 0, and -2, +1, and -1, +2 for 14a. So best I can on this graph, -5, +2, interesting. -4, -4, +1, -3, 0, -2, 1, -1, 2. Make my v. Pretty standard part A, just to get a table of values and graph the function f of x. For part B, I'm going to find f of -x. Do that in the purple still, so that pen's still writing reasonably well. So if f of x equals the absolute value of x plus 3, then f of -x equals the absolute value of -x plus 3. I just simply change the x to a -x. So my answer to part B f of -x equals the absolute value of -x plus 3. Now my standard part C, make a table of values and sketch a graph. For the part C's for the next couple problems, the x's, I'm going to change all their signs because the x has the sign changed in the parentheses. I'm going to change all the signs. And my starting table for this one, when I make my column of points, I'm going to get x and f of -x. I'm going to take each one of these and change their signs. So I'm going to go +5, +4, +3, +2, +1. Now I'm going to get my y's by graphing on my calculator absolute value of -x plus 3. So I'm going to go y equals clear math number absolute value -x plus 3. Because the negative was in the parentheses, it stays in the absolute value. And then second table, and then I got to go all the way down to 5. Next to 5, I see 2. Next to 6, next to 4, I see 1. Next to 3, I see 0. Next to 2, I see 1. Next to 1, I see 2. Notice that I've got the duplication of y's again. So for f of negative x, I can, if I'm clever with my x columns, make the y's duplicate. If that's at all ever possible, I make that happen. So I'm going to graph for 14C the points 5, 2, 4, 1, 3, 0, 2, 1, and 1, 2. So 5, 2, 4, 1, 3, 0, 2, 1, and 1, 2. Well, it certainly looks like it shifts the graph to the right 6 units, and that's not the way we're going to describe this. I am not the most visual person in the world. To describe the transformation that occurs for this, which is part D, describe the transformation to obtain the graph of f of negative x from the graph of f of x. How do I describe how these graphs are related? That's a little bit tricky. But what happens if I look at each point kind of has a mirrored image. This point and this point are equidistant across the y-axis. This point and this point are along the same line, equidistant across the y-axis. This point and this point are equidistant from the y-axis, and I'll pull out a different color because of these points here. This point and this point are both 4 units from the y-axis, kind of mirrored images of each other. And this point and this point are mirrored images of each other across the y-axis. What we say for this function, f of negative x, takes the graph of f of x and reflects it about the y-axis. It takes every point and takes it and flips it to the other side of the y-axis, the same distance from the y-axis. This point was 1 unit from the y-axis. Its mirrored image is 1 unit from the y-axis. This point was 2 from the y-axis. Its mirrored image was 2 from the y-axis. This was 4 from the y-axis. This was 4 from the y-axis. The proper way to describe how the graph of f of negative x compares to the graph of f of x is not to say that it shifts 1, 2, 3, 4, 5, 6 to the right. That's not going to be consistently the case. We're going to say that the graph is the same, but it reflects it over the y-axis. So my answer to part D of number 14, we're going to say describe the transformation to get the graph of f of negative x from the graph of f of x. We're going to say we're going to reflect it over the y-axis. So much of the key to these problems is getting these start tables generated perfectly. And for these problems, moving the graph up and down, we're able to use the same x values for my table. For this one that I just did, f of negative x, we're going to switch the signs of each number in the x column. The first 6 problems, we move the graph to the left and the right. Here, we have to subtract, I'll say h, from the numbers in the x column, and there we need to add h to the numbers in the x column. So when we go to do our graphs, if we have an initial graph and we want to make the graph of the transformation, it depends on how the question is described, whether I use the same x values, I add or subtract numbers to the x values, or switch the signs of the x values. It all kind of depends on how the question is posed. So done with part D, moving on to part E. in part E wants me to find f of negative x. Negative f of x. So here, f of x equals absolute value of x plus 3. F of negative x, which I found before, the negative goes with the x inside the absolute value. Here, the negative is in front of the f of x. The negative is going to go in front of the absolute value, and you get negative x plus 3. The answer to part E is negative f of x equals negative absolute value of x plus 3. That's a real subtle difference. If you look at part B, in part B, the negative was inside the parentheses. The negative wound up inside the absolute value, and I changed the signs of all the x's, and it reflected it over the y-axis. For part E, the negative's in front of the absolute value. It goes in front of the function notation, so it winds up in front of and not under the absolute value. When I go to make my table of values, turns out that for these, I can leave the same table. So just like when I added or subtracted a number outside the function, if I multiply a number outside a function, I'm going to use the same x values. So the key to figuring out whether you're keeping the x values from your start table or you're changing is where the number or where the operation is going. If the operation is inside the parentheses, then you're changing the numbers. Inside the parentheses there, I switch the x values. Inside the parentheses here and there, I added or subtracted. After the parentheses, not inside the parentheses in front of the function, you keep the same x values. So when I go to do my table of values for part F of number 14, I'm going to keep those x values of negative 5, negative 4, negative 3, negative 2, negative 1, and 0. So my table is going to have an x and negative f of x. And I'm going to use the negative 5, negative 4, negative 3, negative 2, negative 1 that I used when I graphed part A of number 14. Now I'm going to get my y's by putting this on my calculator. So I'm going to go y equals absolute clear math number absolute value, and then, whoops, I forgot negative first, and then math number absolute value of x plus 3, then second table, next to negative 5, I'm going to get negative 2. Next to negative 4, I'm going to get negative 1. Next to negative 3, I'm going to get 0. Next to negative 2, I'm going to get negative 1. And next to negative 1, I'm going to get negative 2. So those points I'm going to graph. I'm going to just copy them up here. So for 14F, where I have x and negative f of x, the points that I have are negative 5, negative 2, negative 4, negative 1, negative 3, 0, negative 2, negative 1, and negative 1, negative 2. I'm going to plot those points and then describe how the black graph and the red graph relate. So negative 5, negative 2, negative 4, negative 1, negative 3, 0, negative 2, negative 1, and negative 1, negative 2. Draw my V. And this graph is easier for me to see. It's easier for me to describe how the red graph and the black graph are related to each other. Because the red and the black graph and the red graph are just flipped over the x-axis. Every single point has its mirror on the other side of the x-axis. There's the mirror to that point. Here's the mirror to that point. This point's its own mirror, the mirror there, and the mirror there. To describe the transformation from the black graph of f of x to the red graph of negative f of x, we say the graph is reflected over the x-axis. And that's going to be the case for each of the next few problems. If I'm asked to describe how the graph of negative f of x compares to the graph of f of x, it reflects it about the x-axis. That's when the negative is written in front of the function, and the table I use has the same x values. When it's f of negative x, when the negative's inside the parentheses, the graph will be reflected over the y-axis, and when I go to make my table of x values, I switch all the values of the numbers in the x column. I'll flash 13 up for you to give a go. And then I'll do 16. Heck, let me do 15. Yeah, let me do 15. I haven't done any of your homework problems. Let me steal one of your homework problems to give you one less problem to do, and I won't do 16. So I'm going to do your problem 15, and then I just won't do problem 16, which is not the end of the world. 15 and 16 work the same way, but let me knock out one of your homework problems so you have one less problem to do. Sneaking out some graph paper. So for 15 part A, I'm going to do that in black. 15 part A, I'm supposed to sketch a graph of f of x equals x minus 1 squared. For the number in the middle of my x column, I'm going to go x minus 1 equal to 0. I'll add 1 to both sides. And as I sketch my graph, I'm going to put 1 in the middle of my x column. So my table is going to have an x and an f of x, and I'm going to put 1 in the middle of my x column, and I'm going to go smaller, 0, and negative 1, bigger, 2 and 3, and now I'm going to get the y's from my calculator. So I'm going to graph y equals clear, parentheses, x minus 1 squared, second table. Next to negative 1, I see 4, so I'm going to put the point negative 1, positive 4. Next to 0, I see 1. Next to 1, I see 0. Next to 2, I see 1. Next to 3, I see 4. I'm going to plot those points and be done with part A. So for part A of 15, my table had an x and an f of x, and I get the point negative 1, positive 4, 0, 1, 1, 0, 2, 1, and 3, 4. It's going to be a parabola because of the square, so negative 1, 4, 0, 1, 1, 0, 2, 1, and 3, 4, and make my u. Now I'm going to move on to part B. Part B says find f of negative x. So for 15b, since f of x equals x minus 1 squared, this asks me to find f of negative x. I'm just going to make that x into a negative x. I'm going to get negative x minus 1 squared. That's the function. That's the answer to part B. For part C, when I go to do my table for the f of negative x, I'm going to switch the sign of each number in the x column. So when I go to do my table, when I go to graph for part C, for 15c, I'm going to take these x values and make them positive 1, 0, negative 1, negative 2, negative 3. And for my f of negative x, I'm going to enter that on my calculator to get my y's. So now I'm going to go y equals, clear, parentheses, negative x minus 1 squared. That's the whole function, so second table. And next to 1, I see 4. Next to 0, I see 1. Next to negative 1, I see 0. Next to negative 2, I see 1. Next to negative 3, I see 4. I should have done those in red because or some color other than black. So I'm going to graph these in purple. So on my graphs page for 15c, I'm going to graph x and f of negative x using the points 1, 4, 0, 1, negative 1, 0, negative 2, 1, negative 3, 4. First point, 1, 4. 1, 4 is going to be the mirrored image of this point on the opposite side of the y-axis. Then the point 0, 1, that's this point. This point is its own mirrored because it's on the y-axis. And then the point negative 1, 0, which is a mirrored image of this point on the opposite side of the y-axis. Then the point negative 2, 1, which is a mirrored image of this point on the other side of the y-axis. And then the point negative 3, 4, which is a mirrored image of this point on the opposite side of the y-axis. So this is my graph. It looks like it's just shifted, but it's actually reflected. It's actually flipped over the y-axis. So there's my graph for 15C. And if I want to describe the transformation of the graph of f of negative x compared to the graph of f of x, the graph of f of negative x reflects the graph of f of x about the y-axis. So my answer for this is just going to be describe the transformation. It's going to be reflected over the y-axis. Now I'm going to move on and try to squeeze in 15E, F, and G right up on the top here. 15E wants me to find negative f of x. So for 15E, since f of x equals x minus 1 squared, negative f of x, since the negative's not in the parentheses, with the x is going to go in front of the x minus 1 squared. That's going to be my answer to 15E. And now I'm going to move on to 15F, make a table of values and sketch a graph. For negative f of x, I use the same x values. So when I go to do my table for 15F, I'm going to use exactly these x values. So for 15F, my graph is going to have x and then negative f of x. My x values are going to stay the same at negative 1, 0, 1, 2, and 3. And then I'm going to enter this on my calculator. So I'm going to go y equals clear negative parentheses x minus 1 squared. That's that function. Second table, next to negative 1, I see negative 4. Next to 0, I see negative 1. Next to 1, I see 0. Next to 2, I see negative 1. Next to 3, I see negative 4. When I graph those points, and call that 15E. So when I go to do 15E, I'm going to graph x and negative f of x using the point negative 1, negative 4, 0, negative 1, 1, 0, 2, negative 1, and 3, negative 4. So plot those points. Negative 1, negative 4, 0, negative 1, 1, 0, 2, negative 1, and 3, negative 4. And this graph is the black graph flipped over the x-axis. Is exactly the black graph turned upside down. And what we say is that it reflects the graph of f of x about the x-axis. So when I go to do your question G, describe the transformation to get the graph of negative f of x from the graph of f of x, we can say it flips it over, or more properly, it reflects it over the x-axis. So that's the next concept. We have 4 different concepts in this section, and we've done kind of 3 of the concepts so far. We've done shifting graphs up and down by adding and subtracting numbers outside or after the function notation using the same x values in my table. We had shifting graphs left and right by adding or subtracting numbers inside the function notation, changing the x values in my table, and we have reflecting about the x-axis and reflecting about the y-axis. When I reflect about the x-axis, there's a negative in front of the function notation. The table I use has the same x values, and when I reflect about the y-axis, there's a negative inside the parentheses, and I switch the signs of each number in the x column. So the next concept is new, and I don't generally test on them, but I'll throw them on here. All right, so this will be problems 17 through 20. The video may look different because the first time that I recorded problems 17 through 20, I didn't like the way I did it, so I'm redoing it like 3 months later. So problems 17 through 20 are called compressing and stretching problems, as will be the problems 21 through 24. And in each one of these problems, the function we're going to find, we're going to multiply either by a positive number bigger than 1, or multiply by a positive number in between 0 and 1. And what multiplying by numbers do is it makes the graph either wider or narrower. We say that it compresses the graph if it makes it wider, and it stretches the graph if it makes it narrower. If you're multiplying by a number bigger than 1, it's going to stretch the graph or make it narrower. If you're multiplying by a number in between 0 and 1, it's going to compress the graph or make it wider. So let me kind of jump into my problem 18 and then see where we wind up here. So part A, to sketch a graph of f of x equals the absolute value of x. We've done that a ton, so I'm just going to do that really without even any explanation. I'm just going to, on this sheet of paper here, graph x and f of x. In the x column, I'm going to put the numbers -2, -1, 0, 1, and 2. In the y column, I'll find the absolute value of each one of these. The absolute value of -2 is +2. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So this graph is going to go through the points -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And it's just that nice V. Absolute values for me are kind of the nicest functions to see all the changes that we're needing to do, because I don't have the bends that might trick your eyes a little bit. So that's good enough for part A. For part B, to find f of 3x, because that 3 is in a parentheses, when I find f of 3x, the 3 needs to go inside the absolute value. In this function, the absolute value is kind of working like a parentheses. My answer to part B, f of 3x, is just going to be the absolute value of 3x. To get my table of values and sketch a graph for part C, because the change that I'm making is inside a parentheses, I usually don't use the same table that I did the graph that I'm transforming. And if I'm multiplying by a number inside a parentheses, the table that I'm going to create will have each of the x's divided by that number. So to create my table, I'm going to divide each number in the original x column, in this case by 3, because I'm multiplying by 3. And anytime the change is going on inside of parentheses, I generally don't use the same table. And quite honestly, I could, but I like to be consistent. If the change is going on in the parentheses, I change the table. So let me take each one of these numbers and divide it by 3. So my first x is going to be -2 divided by 3. My second x, I'm going to take the -1 and divide it by 3 and get -1 divided by 3. My third x is going to be 0 divided by 3. Any fraction with 0 in the numerator is equal to 0, so I'm going to write 0 there. And then my fourth x is going to be that 1 divided by 3, and then this 2 divided by 3. All right, so now I need to get this in on my calculator and get my y's, because I don't want to do the y's by hand. So y equals clear. I need to graph absolute value of 3x. To do that, I go math, number, absolute value, and then 3x. So again, I did math, arrowed over to number, hit enter on ABS, and then I'm typing 3 and x and closing my parentheses. I think I have a decent enough window, so I'm not going to do anything to it. To get my y's, if I looked at my table, the only number that I see in my table that's in my x column is 0, and the y next to it is 0. To get the rest of the y's, I'm going to do something that might be new. To get the rest of the y's, I'm going to hit my second key, and then the trace or calc button. And then my calculator comes into something that says value. I'm going to hit enter on value. And now I'm going to type the values. The first number in my x column is negative 2/3. I'm going to type negative 2 divided by 3. And then I'm going to hit enter, and it will calculate the y that corresponds to negative 2/3. And it tells me the y is equal to 2. Do it again. Second calc value. Next x is negative 1/3. I'll go negative 1 divided by 3. There's the x column number. When I hit enter, it'll give me the y column number, which is 1. And then second calc value 1 divided by 3. The y column is 1. Second calc value 2 divided by 3. The y number is 2. So I have my table of values. Now I could sketch a graph. I'll plot the point negative 2/3, 2. Negative 2/3 is about there. It's 2/3 the way in between 0 and negative 1, and then up 2. Negative 1/3, 1. Negative 1/3 is about there, and then up 1, and then 0, 0, 1/3, 1, 2/3, 2. Plot it kind of the best I can plot these things. And as I connect these points, what happens is I get that same V shape. It doesn't get moved left or right, up or down. It just gets crunched, and it gets made narrower. And when I go to finish up the stuff for this graph, if I want to describe the transformation, I thought for certain it was going to get narrower. So I would, on my test, I might just say that this graph gets narrower, because that's what happens to the graph. It looks narrower than the original graph. On the little table that I have, it says if we're multiplying by a number inside of parentheses, and if that number is bigger than 1, we say the graph gets stretched. So we can use the words narrower to describe the transformation of the graph that we created compared to the graph of the absolute value of x. Or we can say that the graph gets stretched, or gets stretched. It'll be fine. All right, so part E wants me to find f of x equals 1/3 to the x, 1/3 times x, where f of x equals the absolute value of x. To find f of 1/3 x, because that 1/3 is in a parentheses, the 1/3 is going to have to go inside or under the absolute value symbols along with the x. This would be my answer to part E. Because the transformation is happening inside the parentheses, I generally don't use the same table. To make my table of values and sketch a graph, what I'm going to do to the original x's is I'm going to divide each number in the x column by 1/3, but dividing by 1/3 is the same as multiplying by 3 over 1. So instead of dividing by 1/3, I'm going to multiply by the reciprocal of 1/3. I'm going to multiply by 3. So the numbers in my x column I'm going to get by taking the original absolute value of x and multiply each of the numbers by 3. So as I go to do part G of this, my x column is going to have the numbers -6, -3, 0, 3, and 6. I just took each one of these numbers and multiplied them by 3. And this problem here, that should say f of 3x, shouldn't it? It wasn't f of x. whereas this should say f of 1/3 x. Not that it's going to be readable over all that crud, but that's okay. Now I'm going to get my graph y's from my calculator. So y equals clear, and then math number absolute value. I'm going to put the 1/3 in a parentheses. I'm not sure that it has to be in a parentheses, but I did 1/3 x like that with a couple of sets of parentheses. The absolute value needed a beginning and ending parentheses, and I put the 1/3 in a parentheses. I'm going to get a really wide graph for this. Now when I hit my second table, the numbers I'm going to need, next to -6 I get the number 2, next to -3 I get 1, next to 0 I get 0, next to 3 I get 1, and next to 6 I get 2. So I'm going to plot those points, and I expect a wider graph, because if I'm multiplying by a number that is in between 0 and 1, the graph gets really wide. So the point -6, 2, -3, 1, 0, 0, 3, 1, and 6, 2 are reasonable things to plot. And as I plot these and connect them, the graph doesn't get shifted left or right, up or down, doesn't get reflected, doesn't really get moved, it just gets distorted. So done with part F. I made a table of values and sketched a graph. Now if I want to describe the transformation for me, I would just say this gets wider, because the whole V opens up and gets wider. So that would be what I just instinctively think. When I look at these problems, if there's a number that's bigger than 1 inside the parentheses, it makes the graph narrower, or we can say it stretches or stretch the graph. And if there's a number in between 0 and 1, it makes the graph wider. And instead of the word wider, we can use compresses. So for this part of the table, this says f of a times x, when a is bigger than 0, so it's only working for positive numbers. If a is a fraction in between 0 and 1, it compresses or makes the graph wider. So my answer for part G is this is going to compress. It compresses the graph. All right, so let me flash up your problem 17, and maybe you can push through it right now. Pause the video and give that a go, and I'll go ahead and do number 20. So for number 20, I'm going to start off graphing f of x equals x squared. Let me do that one in pink. So my original function, f of x equals x squared, I'm going to make a table of values and sketch a graph. And we've done this a lot, so I'm just going to ram through this table without doing any explanation. The x's are -2, -1, 0, 1, 2. The y's, I square each one of these numbers. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So this graph's going to go through the points -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. It's just a generic parabola. It's a U as opposed to a V. And so that would be a reasonable step answer for problem 20, part A. Now for part B, to find f of 2x, because that 2x is inside a parentheses, I need to put that 2x inside a parentheses. And that's going to be my find each function. If you wanted to simplify this, you'd get 2x times 2x equals 4x squared. So as for an answer to part B, you can say f of 2x equals the quantity 2x squared, or you can say f of 2x equals to 4x squared. They're both correct answers. This one may be kind of what we're looking for here, because you can kind of see how this matches up to the original problem better. To make my table of values, because this number's inside the parentheses, I need to change the x column. I'm going to change the x column when I go to make this table of values. I'm going to divide my x's by 2 as I go to make my x column. So when I go to graph this function that has f of x, it has x, and f of 2x, I'm going to take each one of these numbers and divide it by 2. For my x column. So -2 divided by 2 is -1. -1 divided by 2 is -1/2. 0 divided by 2 is 0. 1 divided by 2 is 1/2. 2 divided by 2 is 1. Now I'm going to enter this function, but I could also enter that function. They're equal to each other on my table calculator so I can get a table. So 2x squared, graph it. It's going to be a skinny parabola because multiplying by a number bigger than 1 makes the graph narrow. And then second in table, let me see, next to -1 I see 4. I don't see a number next to 1/2. I'll get that in a second. Next to 0 I see 0. Next to 1 I see 4. To get the fractions entered, I do go second calc, hit enter on value. I'm going to go -1 divided by 2, and that gives me 1 next to -1/2. And then second calc value, +1 divided by 2, and I get +1 next to +1/2. So my tables of values, I'm going to plot those points. I get the point -1, 4, -1/2, +1, 0, 0, 1/2, 1, and +1, 4. It's the same shape. A parabola is not going to change to something other than a parabola, but it just got narrower. Anytime I multiply by a number bigger than 1, it's going to make the graph narrower. When I go to describe the transformation, which is the end of what I need to do for this graph, it says describe the transformation. For me, it's just obvious to say that the graph got narrower because it looks skinnier. The other thing that we could say, if we're multiplying by a number inside the parentheses and that number is bigger than 1, the word that we can use instead of narrower is the graph gets stretches. So we can say it gets stretched, or the graph gets, yeah, it was stretched. I think that's a good enough word. Those we can use interchangeably. All right, for part E, to find f of 1/2 x, the original function for this group of problems of f of x equals x squared. F of 1/2 x is going to be 1/2 x quantity squared. That actually reduces to 1/4 x squared. This would be the answer that I would expect for part E. But it would be okay if you said f of 1/2 x equals to 1/4 x squared. If you just instinctively knew how to reduce that properly, that would be fine. I'm not going to explain how to do that. If you did it because you know how to do it, that's fine. But this is where I would leave my answer. Next part, make a table of values and sketch a graph. I need to divide the numbers in the x column of my first graph by 1/2, and that's the same as multiplying by 2, because dividing by a fraction is the same as multiplying by the reciprocal. Dividing by 1/2 is the same as multiplying by 2 over 1. That's the same as multiplying by 2. So when I go to do my table of values and sketch a graph on the next sheet of paper, or the last sheet of paper, I'm going to multiply all those numbers by 2. So for my graph here, I'm going to have an x column and an f of 1/2 x column. I'm going to take each one of these x's and multiply it by 2. I'll get -4, -2, 0, 2, and 4 as my x's. And then I'm going to enter this function 1/2 x squared on my calculator. And on my calculator, I'm going to have double parentheses. I'm going to have the 1/2 in a parentheses, and I'm going to have the x, the whole function, in a parentheses. So I'm inserting an extra parentheses when I go to do this graph. So I'm going to have two sets of parentheses when I enter this in my y1. So for my y1, y equals clear parentheses, and then parentheses 1 divided by 2, x parentheses squared. It's going to make a really wide graph. Now I'm going to get my y's. Second table, next to -4 I see 4, next to -2 I see 1, next to 0 I see 0, next to 2 I see 1, and next to 4 I see 4. So I'm going to plot those points. So the point -4, +4, -2, +1, 0, 0, 2, 1, and 4, 4. It's going to give me a really wide graph. Because when you multiply by a number that's in between 0 and 1, it makes the graph wide. So that's the end of part F for problem 20. I've made a table of values and sketched a graph. And if I want to describe the transformation, I would say the graph got wider because that's what it looks like to me. The proper thing to say, if you're multiplying by a number inside the parentheses, if the number's in between 0 and 1, we say the graph gets compressed. So we can also use the word compress. Compress and wider we're going to use interchangeably. Narrower and stretching we're going to use interchangeably. All right, let me flash up, just in case, your problem 21. So pause the video and give that a go. And I think I'll stop. Hold it. Is that all I'm supposed to do? Oh, that's for the next section. Not flash that up. That we'll do in the next section. Ignore that. Let me flash up problem 19, which is the problem that kind of mirrors the problem that I just did. So I'm going to stop the video here, and that problem 21 that I just flashed up, I'll put in a part 4. And part 4 will be the last part of this section. Oh, right. Hopefully things are going okay.